We're in your geometry and we're on section 6, or chapter 6, section number 7, the measurement of the area of a circle. Now we're talking about area. So remember, area is always going to be dealt with in squares, square. So just keep your mind, area, you're going to be dealing with squares and square roots and such when you talk about area. So the area of a circle. The area of a circle is the area of the surface enclosed by the circle. That means this whole area. If we took this here, it would be this whole area on top, would be the area of the circle. So theorem 83 says, the area of a circle is equal to 1/2 the product of its circumference and its radius. So if you want to find an area, there's different formulas, but this formula we need to know is basically going to be, whenever you have area, remember they always put K because they don't want to mix it up with apothegm or something else. So they put a K for area. Just remember that they're using a K. So area equals 1/2 the circumference times the radius. So that's a good formula to know. So it's going to be here's the circumference. The area is going to be 1/2 the circumference times the radius. So you just take the circumference and it's going to be 1/2, basically take 1/2 the circumference times the radius. Circumference times the radius, and then half it. That's going to be area. Okay? So that's number one. We should remember this when I go back. We're going to have to use that formula, all right? So let's go on to the next. Corollary 83.1 says, the area of any circle is expressed by the formula K equals pi r square, or K equals 1/4 pi times the diameter square. Those two formulas we got to know. In fact, you probably are familiar with this because you probably, actually in grade school, they start teaching this. Basically area equals pi r square. The area of a circle is pi times r square, which is the radius. Or if you want to use diameter, then you're going to have to say the area equals 1/4. Remember, this will be a test question. They'll say, is it 1/2? No, it's 1/4 because you're squaring 1/2. So it's 1/4 pi d square, because this whole thing has to be squared. So just remember, if they're going by diameter, if you're going with d square, then you're going to have to take 1/2 d. No, you take 1/4 of d. So when you're using d, because of the square of instead of 1/2, the square of 1/2 is 1/4. So it's 1/4 pi d square. That's for the diameter. But otherwise, the simpler one to use is area equals pi r square. You should know that too. If you've had it probably since you were in grade school, like I said. The corollary 83 says, the areas of two circles are to each other as the squares of their radii, the squares of their diameters, or the squares of their circumferences. Circumference. Okay. So we have here K being area. So one compared to the other, one circle compared to the other, or the ratio is going to be K to K. But if you're going to use the radius, you're going to have to square the radius. So the square of the radius and the square of the radius, or the diameter, you're going to have to square it, or the circumference, you're going to have to square it. So let's go on to sector of a circle. I think this goes on to the next section, and we're going to have a quiz then. So a sector of a circle is the figure formed by two radii, which that means radiuses, and the arc intercepted by them. So a sector. So basically you need to know, what is a sector? It's the figure formed by two radius and the arc. So if you have this here, this picture here, can you see it? Circle. You're going to have two radius here, and you have this arc. And this section is going to be this section of the area of this section here. That section that's cut out like a pizza right there. Got it? So in the same circle or in different circles, similar sectors, similar arcs, and similar segments are sectors, arcs, segments that correspond to equal central angles. So basically corresponding to that central angle. We'll have the arc, similar sections, they have to be the same, you know, there. Corollary 83 3 says, the area of a sector of a circle is the area of the circle as the angle of the sector is to 360 degrees, okay? So need to know this because this will be probably what to use as a formula. So you have the area of the sect, they have sect there, means sector. That's the section, I say. The area of the sector or the section of that is divided by 360 degrees is the whole circle, right? So whatever section you have, you need to actually divide that by divide that by 360 degrees, or that over 360 degrees. So the area of a sector is equal to 1/2 the product of the radius and the length of the arc. So another formula, the area of a sector is going to be 1/2 the product of the radius and the length of the arc. So 1/2 radius and arc. So what is the formula for the length of an arc? We're going to use it in, to use this basically, we're going to be able to use this. Actually, you always just go back to this one, it'll be easier. So the area of a segment of a circle whose arc is a minor arc is equal to the area of the corresponding sector minus the area of the triangle formed by 2 radii and the chord of the segment, okay? You're going to have problems like this. You're going to have to find this section. Say you had a section like this here, and you drew this here, and you need to find this little section here. Then you're going to have to subtract that triangle from it to find it. We'll be doing that probably do it on your test. It's probably the hardest to do. It's going to be on it's going to be on this quiz, and then you'll have one on the test. But whenever you're doing a test, I always, when I come to a really hard one, I finish all the easy ones. I skip it and I finish all the easy ones first, then I go back to it, because sometimes if you don't have enough time, at least you're not going to have to stop right there and not finish the whole thing and flunk the whole test. So skip it. If you have a hard question, skip it and come back to it. Always do that so you don't waste your time on it, in case you don't have enough time to finish it, because this will be a long one. So, all right, let's see this last corollary here. Similar sectors are to each other as the square of their radii. So now we're talking about the sectors, the areas of the sectors. Remember I said area are going to be similar to the squares of their radii, which we've had already. So let's go on to the quiz. First four questions are going to be easy. This is the last one. So the last one's actually probably going to be the hardest one, because it has a lot. It has like 3 different parts to do in it, and it'll probably be the hardest one in this whole chapter, your whole chapter in test 11. So anyway, quiz 48 says, find the area of a circle that has a 4-inch radius. How easy is this question? So we're going to find the area. The area of the circle equals pi r square. So we plug in 4. So we have area equals pi times 4 square. So k equals 4 times 4 is 16. So we have 16 pi is the 16 pi square inches. Now they're not asking you to get your calculator and figure out pi in. They just said just leave it as a radical. So we can just say it equals 16 pi square inches. Make sure you put that square inches in area. Oh, easy one. Let's go on to the next one. Find the diameter of a circle that has an area of 16 pi square inches. So do you remember our area formula, or our area formula for a diameter? So we have the area of a circle equals 1/4 pi times d squared. Of course, radius is going to just be pi r squared, but now we have to go twice that, but instead of twice, we're going to be 1/4. Instead of 1/2, we're going to go 1/4 because of the square. So always make sure. So this is the one you need to memorize. That's for diameter when you're using the diameter of a circle. So you actually, you know, in the midst of this, you could take half of this, but we're dealing with pi in there, so. So now we have, plug it in. What is the area? It's find the diameter of a circle that has an area of 16 pi. So we plug in, the area here is 16 pi equals 1/4 pi times d squared. So now we can basically take the pi out of this side, because we put over on this side, and we can actually divide this both by pi and get rid of this pi. Yay! So the pi is not going to even be in our answer. So we got rid of the pi. Now we have 64 equals d squared. So now we're going to do the square root of 64. Just happened to be easy. 8 times 8 is 64. So 8 is going to be our diameter. 8 inches is our diameter. 8 inches, and the square is going to be 16 pi. So if you have an 8-inch diameter, of course the diameter is not going to be in square inches, because the diameter basically is this line. It's going to be 8 inches. So that was pretty easy too. So let's go on to number 3. Find the area of a 60-degree sector of a circle that has 5-inch radius. So now we're going to use this sector formula that we just learned. So the section, I say sector, but a section means a section. And what is that again? It's going to be the section, the area of 60 degrees sector of a circle that has 5-inch radius. So remember we went here? This here, K sector divided by the circle. So let's do that, which is 360 degrees. So we have K sector, and this just means as a placeholder that you're going to put something in there, divided by 360 equals what? We're going to put pi r square, the circumference, right? Or not the circumference, but the area, I'm sorry. The area times 60, because you have 60. The area is 60. So area pi r squared times 60, and we're going to divide it by 360. So we do this down here. So we plug this in. So we have pi times what? 5 inches. Let's put the inches in there. Square. So we just plugged in radius here. Times 60. Just plugged in 60. So now we have pi, and 5 times 5 is 25. So pi times 25 times 60 over 360. Well, if we look at this right away, we can reduce this. 60 goes into 360 6 times. There we go. So we got rid of 360. We got rid of 60. So now we have 25 pi divided by 6 square inches. Now we can't reduce that because 6 doesn't go into 25, so we just leave it there. 25 pi divided by 6 square inches is the answer. All we did was plug this in with this, with our number that we had, with the circle pi r square, and then put in the degrees, 60 degrees over 360. So same as in the book. Number 4. This is another pretty easy one, actually. Find the area of a circle. The circumference is 8 pi. Okay? So here we have, first of all, the circumference is 8 pi. We need to know, to do the area, we need to either have the radius, which is r, or the diameter. So one of the two, to use those two formulas. So we have to find from the circumference what the diameter or the radius is. It's best to find the radius because that's the easier formula. So here we have circumference equals d times pi. So basically we're going to say the circumference equals, we're going to plug in, we're going to plug in 8 pi, right? So here we know, if we plug in 8 pi, we know the diameter is going to be what? 8. So the diameter equals 8. So if the diameter equals 8, this diameter is 8. What is the radius? It's going to be half of this. It's going to be 4. So the radius, if the diameter is 8, the radius is going to be 4. So So now I can plug in my area formula, which is the area of a circle equals pi r squared. So now we have the area of the circles equals pi we plugged in, and we plug in 4. We found out the radius is 4. So we're going to plug it in there. So pi 4 squared. So now we're going to have area equals 4 times 4 is 16. 16 pi square inches. Now again, you could plug in pi and get the exact, well, not the exact, because it's never exact, but you plug in with 3.14 if you want to, but they don't want you to do that. They want you just to leave the pi. So we have k equals 16 pi square inches. So that's an easy one too. But first, if we have a circumference, we have to find out the diameter. And so we plug that in, 8 pi, finding, the diameter to be 8, and then we want to find the radius, which we found the radius is half of the diameter. And then we just plug it in. Pretty easy, just a review. Now the last one. Let's see. Quiz 48, number 5. Yep, this is it. This whole paper has to do with this last one. So if you're going to miss a question, this would be one to miss, but let's plug through it, and I think you'll find it's not as hard as it seems. And because we're doing each part, this has 4 different parts, 4 different things to find it. We can go in, like put on our Einstein helmet or whatever, to find out, as going through this, little part by little part, we can get through it. And if we get the first part right, then we probably could have the right answer. So anyway, quiz 48, number 5. All it says is find the area of a segment of the circle if its arc is 120 degrees and its radius is 3 inches. So this is what it looks like. You got to get, okay, what are they talking about? So here's a circle. And so we want to find the area of a segment of the circle is 120 degrees. So this is 120 degrees right here. So we find that's part of the circle because the circle is 360 degrees, but it's 120 degrees. And so that arc, is 120 degrees. We put a line there because that's this arc here. And its radius, here's its radius. Its radius, the radius to each, wherever the radius is going to be 3 inches. And so now we want to find what we're looking for is going to be part of this circle. So we want to find the area of the segment of the circle, this segment. So we're looking for this whole area, kind of shade in a little bit. If you shade it in, we're looking for that area. Okay? So how do we do this? Well, we got to subtract, we're going to have to subtract a couple things from that, aren't we? So in this area. So first of all, we're going to have to find this triangle, because we are going to have to subtract this triangle from this, right? We know that. So to find the triangle, so we have the triangle here, and this is the line of the arc, right? And here's the radius and this radius here. So now we want to find this is the triangle ABO, which ABO is this triangle here, right? So we want to find that. So to find this, we need to know the base and we need to know the height. Well, this isn't a right triangle, so we can't say the base and the height unless we have a right triangle, but we can divide this in two. Apothem will divide it in two, and so we can get a little right triangle. So let's take this little right triangle out and we'll put it over here so we can see it better. Because in that way we can find the base and we can find the height to get this triangle, because we know how to do this, right? So we have, this is OM, this is the apothem. We don't know that one yet, but we actually do know it. But here we have this, we know that this radius here is 3 and this is 3. So this is 3 and this is 3. And this here, OM, let's put OM there so you can see it better, OM. And we know that this bisects, basically, as it bisects, we know that, of course, OM, if it bisects, it's going to be the apothem, as the apothem actually in the triangle there bisects. So we know that it's going to be half, it'll be 3, section 3 divided by 2 is going to be the Potham. So we know the Potham is going to be 3 divided by 2. Now we have to find this here, and then we'll have to find this. But the reason we want to find AM here is because we want to be able to do the Pythagorean theorem, right? We want to do this, knowing this is already, because a Potham cuts this in half, so we know we can do. So we want to find this because we want to find what this is. If we find what this is, then we can double that and find what that is. Okay, what AM. So now we're looking for what AM is. Well, then we can do the Pythagorean theorem on this. So we have the Pythagorean theorem, a square now for this, a square plus b square equals c square. Well, what we have here, we know the circumference is 3. We know that this is 3 because this is a radius. So we put 3 in, and we know that this is 3 halves. So we have 3 halves. So now we have a square plus 3 halves square equal 3 square. And so let's go ahead and go on. It's going to be a square plus, and 3 halves times 3 halves is 9 fourths. So 9 fourths and then 3 squares is going to equal 9. But we want to put it in fourths because it's too hard. We need to use it basically so that we can divide it in. We can't use we have to use a total fraction, not a fraction that's a combination. So we end up a square equal, and I changed this to 36 fourths because that would be 9. 36 fourths minus 9 fourths equal 27 fourths. So now a square, we're going to have to do the square root of 27 fourths. So we look on this here, we'll find out 27 fourths equals 9 times 3 in there, so it's going to be 3 times the square root of 3 over 2. So 3 times the square root of 3 over 2, and now we know that's what this is going to be, AM. But we're going to need to know the base, which is going to be this length, so we're going to have to divide this by, or multiply this by 2. So you got AB, this line here, is going to be 3 times the square root of 2. Now, all that to find out the area of a triangle. And so let's go back to the area of the triangle. Here's the area of the triangle. An area of a triangle equals 1/2 base times height, right? So now we have 1/2 AB, this is AB, or this here, AB, base times height. So 1/2 AB, so we're going to put down 1/2 AB is the AB line is what? What answer did we get here? We got the AB line here. 3 times the square root of 3. So we plug that in, AB, 3 times the square root of 3. We put the height here is going to be 3 halves. We already knew the height is OM. It's going to be 3 halves. So we plug that in. So we plugged in 3 halves, and so we times 1/2 times 3 halves, and we get what? 3 fourths. So it's going to be 3 fourths times 3 times the square root of 3. Also, we times 3 times 3, so we have 9 fourths times the square root of 3. So this is going to be our area of our triangle. So now we have to find the area of the circle, which is going to be a lot easier. The area of the circle, in doing this, is going to be, an area of the circle is pi r squared. So we're going to plug in pi and then put in the radius. We already know from the beginning of the problem that the radius is 3 inches. So we just plug in the radius. So I plugged in the radius and it's 3. So we have basically the circumference, or the area of the circle is going to be 9 times pi. So this is our answer, the area of the circle. Now we want to know the area of the segment, right? And we have a formula for this too. So let's go to the area of the segment here, or the area of the section, I should say, the area of the section here. So you have basically the area of the section over the area of the circle. So the area of section is going to be, and you plug that in, over 360 degrees. And so we put in pi r squared, with that area over 360. Okay, so let's go up here. So we put in pi r squared is, we found that the area there being 9 pi, right? Because pi r squared, we found it right up here, pi r squared being 9 pi. So 9 pi times, what does it say our arc is? 120 degrees. So we're going to put in 9 pi times 120 divided by 360. 120 goes into 360 3 times. So we can get rid of the 360 and the 120 and just put 3. So now we have 9 pi over 3. So the section is going to be 9 pi over 3. We can reduce that. 3 goes into 9, so it's going to be, the section is going to be 3 pi. And so in the midst of this 3 pi, now we have the answer. So now we want to know the segment. So the segment is going to be the section minus the triangle. So this segment, that's where we found this. This whole area here of the triangle, and that is basically going to be the section. This section is what we found, right? Now we have to subtract that triangle to get that little segment, right? So the segment's going to be 3 pi, that's that, the section minus the triangle. So let's see if I can put this in here right. There you go. Let's put it here. So it's going to be the segment. The segment equals that section minus the triangle. So it's going to be, the answer is that section is 3 pi minus this triangle, which we got up here as our answer. Remember, 9/4 times the square root of 3. So our answer is going to be, and you could put in pi if you want to, but they said not to. So we have 3 pi minus 9/4 times the square root of 3, and that's going to be our answer. So basically, this whole thing, first thing we did, we had to find the area of this triangle. And that took us a while here, right? And finding the area of the triangle. We found the area of the triangle first, because we knew we were going to have to subtract it from this whole thing. And then we had to find the area of the circle, this whole circle area. We found the area of circle very easily. But then we had to find the area of just this segment of this arc, which is right here, which is all this. So in doing that, we used the section right here, the section. I call it a section instead of segment. And so we used this formula here, and we got 3 pi. 3 pi being the answer of that. And so now we found the area of the circle, there. So we found the area, basically the area of the circle, so we found this section, what this section was. And then in the section here, to find this little segment here, we had to subtract that triangle, and then we get it. And that's the answer. So, yay, we did it.